My name's Jamie Kuhl. I'm the lead program manager for Build, Version Control, Web Access, and the Team Foundation server team. With me, I've got Brian Randall, senior consultant, MCW Technologies.
Yep.
Microsoft MVP.
And general troublemaker.
Yes, that goes without saying. So I'd like to thank everybody for coming to the talk. I know this is the last session of the conference. I know many of your colleagues have made the incorrect assumption that the conference is actually done. Luckily, you guys have reviewed your done criteria a little closer and realized the conference is actually not done. Out of curiosity, how many people out there already know what I mean by done? All right, about half. How many people actually came here just to find out what the heck done means? Yeah, that's what I thought.
Because Jamie, I need to know too, man.
Yeah. Well, hopefully by the end of this, you'll have that figured out, Brian. So, done refers to this agile programming concept of what does it really mean to get your software done. Usually in the context of agile, when I say agile, you're thinking, project management, right? Like building user stories and product backlogs and planning poker and burn down charts and that kind of stuff. But there's another half to agile, which is all about engineering practices, right? Like continuous integration is probably the best example. There's a set of these engineering practices that if you can adhere to them, if you follow them, generally your development process is just going to be a lot better. And that half of agile is what we're here to talk about today. And specifically what we're going to be talking about is how we can use the new version of VS, the new version of TFS, to help you get your software done, help you keep it done, and help you actually know that you're done. So that's the general theme of what we're going to be doing today. So most of today, what we're going to do is we're going to be taking an app that all it does is build and get it to a point of a reasonable level of done. Get some automated builds, some gated check-ins, some automated tests, deploy this thing out automatically to a lab. We're going to have the Nirvana done scenario built by the time it's all said and done. Now, before we dive into that, I'm going to do a little bit of setup, level set, and get everyone on the same page. But I want to go ahead and let Brian let loose on building an app for us first, because the first thing we need is an actual app. So what are you going to build for us, Brian?
Well, we've got less than 60 minutes now, so I'm going to build the canonical demo app. Not Hello World, no, a calculator. Can you guys work on that with me? OK. So while Jamie gets this intro going, because he, for some reason, thinks we need to have some slides to set context. It's like, tell a story.
I'm a program manager, OK?
I know, yeah.
I can't do zero.
So I'm the developer. I'm going to build a quick WPF calculator that talks to a class library and get some code ready for us to build it, and we'll get done. So start now. You start blabbing, and I'm going to get something crafted up now. OK, I'll take care of the blabbing.
OK, so I want to talk first about a typical scenario that is a lot more common than we'd all like to see it. Let's start by going through a development workflow here. This is one that I've seen more times, many times out in the wild. Step number one, dev writes some code. Step number two, dev makes sure his component compiles. Not necessarily the entire application, because the application could have lots of components, lots of things from different people. He makes sure his compiles. Then he checks in his code. Then he does this again and again and again for 4 weeks, whatever his sprint iteration that he's working on is. And you got about 15 devs or whatever the number is doing this again and again and again. And at the end of those 4 weeks, the dev lead or somebody in the team does a build of the entire stack, the entire application. That's the drop, right? Now you're ready to make the drop. You get the app installed in the test environment. Because I've been in many organizations where really the app will only run in two places, in the production environment and in the test environment. And in some places, they're one and the same. Now, you get it installed, and then test tries to test it. And then, of course, what happens next? It doesn't work. And then what happens next? Dev blames test, right? And then generally badness ensues. Now, what's going wrong here? The problem that's going wrong is this is the extreme example, but this is the extreme example of waiting to get all of the things that you'd think of as being done with the software until the very, very end, right? As opposed to pushing them to the front. Now, the reality is we all work in cycles, right? Like you go through a cycle where you're just doing check-ins, multiple check-ins a day. You go up to your daily build, all the way up to getting the product done. And somewhere in between there, you've got stories and iterations. And each of these cycles that you work in, they all have their different levels, their different definitions of done. When you check in, you better be sure the whole thing builds. That's a level of done you want to make sure you have where to check in. But you might not want to make sure that every single perf test, every single stress test, everything is absolutely done. You might not want to make sure every bug's fixed. But by the time you finish an iteration, you want to make sure that every single bug is fixed. So they all have their different levels of done. And the more that you can push getting done to the left, the more you can push it early in the cycle, the better your quality is going to be. Because you've kind of got these trade-offs, right? Deferring done has costs. We just talked about the worst case scenario, you defer it all to the end. You get low build quality, you find issues late, you don't really know where you're at. But achieving it early also has costs, right? If you had to go validate, your done state, all of the criteria that you have to be done manually, that's too expensive, it's too error-prone, it's not practical. You could go automate all this stuff, but when was the last time that management told you to invest in automating your done criteria, automating things as opposed to going and investing in the product? It's a hard trade-off to sell in a lot of situations. So more often than not, the notion of deferring this cost is made just by default as opposed to any real conscious decision that goes into it. So the thing we've tried to do with the new version of VS, new version of TFS, is give you all the building blocks you need to get to this reasonable level of done yourself. So a big investment has been going into automating done. So you want to be able to get as much of it automated as possible. So we've given you a bunch of infrastructure, from build infrastructure to validation, layer validation to deployment to test automation and execution and reporting of all this stuff. We've given you a bunch of infrastructure. This is going to let you focus on building what's unique to your application. We've also, the nice thing about this too is we're going to go through a whole scenario in a minute, right? We're going to go from kind of start to finish, and it's going to be, everything automated from start to finish. You don't have to do everything. If you just take one piece of what I show you today, you're going to get a lot of value out of it. We also help you enforce done at each cycle, meaning you may define what your criteria is for check-ins, for what it means for each one of those cycles. But just defining that isn't enough to make sure that the principle is being applied. You'd like to make sure that if you have a policy for check-in, if you have a criteria for what it means to be check-in, you can enforce that for all of your check-ins. So we help you automate it, we'll help you enforce it, and we help you know. We have a bunch of reporting stuff in TFS, from test reports, just basic project data reports, build reports, a whole bunch of infrastructure and reports to let you know where you're at. And we're not going to focus so much on knowing when you're done today, but more focus on the automate and enforce. Okay, so our scenario that we're going to do right now, we've got an app, and apparently it's a calculator app today. The app, all it does is run and hopefully build in Visual Studio, but Brian, you're doing a lot of...
You're really making fun of my code already.
You're doing a lot of typing over there. You're making me a little nervous, honestly.
Hey, it's just some XAML, man.
We also have a fully configured TFS and VS Ultimate 2010 edition. This is all based off of the beta 2 bits that are available right now. What we don't have anything else. We don't have automated builds. We don't have automated tests. We don't have any setup packages. We don't have anything else. This is all we have at this point. So what we're going to achieve in less than an hour is we're going to get some automated builds going, some validated check-ins with gated check-ins. We're going to write some unit and acceptance tests. We're going to write deployment models so you can deploy the application after it builds out to a lab environment, run the test, get the data back. So step one, automated builds. So if you don't have an automated build, out of curiosity, how many people out there have a fully automated build? Congratulations. That's no small accomplishment in some situations. But if you don't have one, no single engineering improvement investment you can make is going to give you more bang for your buck in terms of improving your engineering practices. You got to build the whole thing at the end anyway. You might as well just do it up front and do it every day. So with VS and TFS, we made it a lot easier. I consider myself to be a kind of a dev lightweight. Brian's more the dev heavyweight. But I can do make scripts. I've done that stuff in the past. But how we build, how the build lab works and that kind of stuff has always been this big mystery. But the nice thing now is with Team Build, it's not. If you have any project that builds in Visual Studio, you can have an automated build in seconds. And you can go from that simple case to complex cases very, very easily. We integrated the Windows workflow engine into Team Build in this release, so you can go from the example we're going to show you, which is one build of one project on one machine, to multiple builds in a build lab across many machines, executing in parallel. In fact, you can execute the same build in parallel across multiple machines. So it's fully extensible from top to bottom. So the first step is, Brian's going to show us that we actually, in fact, have a working application, and then we're going to turn on an automated build for it.
Okay, so I got done just in the nick of time to hopefully get Jamie to stop blathering for a second. Love you as much as I do. They really want to see something work. Now, once again, I'm going to impress you with my coding prowess. Press F5. It works on my machine. You, sir, in the front here, in the cap, yes? Give me a number, please. An integer, right? Nothing too giant like some 7. And gentleman next to him in the red? Yes, you? 35. So doing some math, 42. It always is 42. And you're more than impressed with my coding prowess. Thank you. Have a good show. Thank you. All right, that probably doesn't cut it. All right. Now, once again, it works on my machine. I've got a class library. I've got a WPF app. I think it's ready to check in and give it to the rest of my team, right? So let me check it in. And if I could right-click, select check in. Same dialog you're used to seeing if you're using TFS already. So built a new shippable application. And I'm a good developer, so I'm going to go see, make sure I have a work item for this. It turns out, yes, get done. So we'll check that. I'm going to associate, because I know Jamie's not going to let me be done, being the PM that he is. We'll check this in, and now it's in version control. But the problem with this is that it works on my machine. And we know there can be variables in the fact that I might have extra libraries installed. I may have done something funky with my configuration, hard-coded paths, et cetera. So we really need a team build. And the good news is if you're used to 2008, this is very similar, but richer underneath the covers. So I'm going to right-click on the builds node. I'm going to say new build definition. One of the nice things that you'll notice is that right away I have a name. They took the fact and said, well, you got the solution called PDC Live. Maybe you want to use that as your default. If not, you can change it. This is my first build at PDC. And then you'll notice as we go down the list here, we have things like trigger. We'll come back to that. And then workspace. How many are familiar with this option and why it's important? All right, I'm not seeing all the hands go up. So either you're lazy and you're tired of raising your hands, or you don't know what it is. Really simple, but super important, and this applies to 2005, 2008, and 2010. This is going to control what code the build service pulls out of TFS, out of your version control repository, and puts on the build machine to compile. If you leave the default, which is the only good default they could come up with, it's going to start pulling over time your entire repository. So for example, anybody check in their tools like Visual Studio into version control? No one? Okay, wait, I see one hand. Thank you for saving me for that. Okay? Over time, as your repository gets larger, you're going to be checking that all out. So what we're going to do here is drill down into my repository and pick an area of my repository that contains just the bits I really need. In this case, under source, PDC Live. Now by doing that, I'm restricting what does on a get. Now, you'll notice for the next step, build defaults, it's telling me which controller it's going to run on. Once again, they made some enhancements to the architecture to support what we call build agents, greater scalability, greater flexibility. But I still need to tell it where I want to put the output of my build. So we'll change this to build x64, and I have a folder called drops already mapped out and shared. In other organizations like Microsoft, for example, they use a large distributed share for all the dev builds because they got, what, you got 20 some odd build labs that all feed into it. So you might want to use a file share instead, but for this example, my build server. But here's probably the big change that is really new, the new process tab. What we've done now is we said, you don't have to go poke around in this XML configuration file to customize the behavior of your build. You can go to workflow if you need to, but a lot of this stuff has been surfaced right up here for us to use. First thing you'll notice is because I filtered down the workspace setting, they're able to guess that, you know what, we see one solution available at that point in the repository. We guess you probably want to build it, so let's save you some effort. In addition, they've turned on a lot of good defaults. I'm really done. I can actually save this, right-click, and queue a new build. Lots of options here. You can control incremental builds, et cetera, but I'm just going to hit queue. And I've got this habit. It goes back to doing MTS. Anybody do MTS in the 90s? Remember the spinning balls? Woohoo! Well, team build, we don't have spinning balls, but we do have a new build report. Now, what's cool about this build report and why it was redesigned, number one, is because the team build engine now, being built on top of workflow, supports parallel execution. So you can actually have multiple sections executing simultaneously at the same time. So what we see here is initializing variables, doing all the good stuff. You'll note we got this little plus minus. Ooh, zoomy feature. Okay, not that that does much good at that depth and resolution. We're going through doing that, and I see green. Yes! Can I ship it now?
Not quite.
I'm not done. Okay.
So we do have an automated build. That's a great first step. Switch me over to slide. Okay, now that we've got an automated build, there's all kinds of ways to actually leverage the fact that we have an automated build. First feature, continuous integration. So continuous integration is a great way to take advantage of builds. It basically is a model where, if you're not familiar with it, you're able to just continually do builds and look for errors. So if you ever get a check-in that's bad, an error introduced, any kind of problem from integration, you're going to find it very quickly. It's a great way to constantly reassess your done level. We've had this feature now for one release inside of Visual Studio. The nice thing about it is there's no really special work to go do it. It's one option to go turn it on. As long as you've got the processing power, as long as you've got the hardware, the CPU cycles to run the builds constantly, you can take advantage of CI. Now we've got a new feature in 2010 called gated check-in. And you can think of gated check-in as kind of a pessimistic CI. CI is kind of optimistic, right? You check the stuff in and then you check to see if you had any problems with it. With gated check-in, you're saying, I want to assume that there might be a problem and do the build before the thing even gets checked in. So with gated check-in, you're able to have the developer do a build, instead of getting checked in, it gets shelved to the side, build happens automatically. If the build succeeds, gets checked in, build fails, goes back to the dev to go fix it. Now this is a really cool feature from the integration standpoint, because to do this, you need to have an integration between the build system and the developer tool. Because if you don't have that, which is a nice thing that TFS has, if you don't have that, then you can't get the workflow right. Because this is really, modifying your developer's check-in workflow to make it go good. So Brian, we've assigned a set of criteria. You want to make sure that everybody's build is good. Everybody's build at least builds before it goes in.
Okay.
So let's make that happen.
All right, so what you saw before is I defined a build. And when I define this build and kick it off, I did it manually. So we could do continuous integration, but what we want to show is that we now have this feature called a gated check-in. And it turns out, all we have to do is come over to our build, called PDC Live, go to Properties, go to Edit Build Definition, click on Trigger, and you'll note that underneath here we still have manual, we have continuous integration, they've renamed the continuous integration with delay called rolling builds, and then we have gated check-in. Just change that option, save it, and now we've changed the behavior of the build. Now to be clear, this is one of those additional guidance mechanisms you can use with your developers. It's not meant to be draconian. What it's meant to do is put them on the path to success. This first started in Team Foundation Server 2005 with what we call check-in policies. So you notice I don't have any, but I can still turn them on. For example, I could suggest that developers have a work item before they do a check-in. So we'll turn that on, because that's a good thing to have. So you still have your check-in policies as a way to make sure people are doing the right things before they check in. But now we're saying, hey, I love you guys, but there is a chance that you might not get it right. Now, because we've made this change, I need to modify some code, right? We know my current code, the way it is, works. In fact, you know what, Jamie? It might be good if we actually got you to do some code, because I write perfect code all the time. Anyway.
What are you saying there, Brian?
Well, you're doing kind of a desk job, let's be honest, as a program manager.
Okay, what do you want me to add here?
Well, I think what we need is a subtract method, because we can add, and it's always good if your bank account is adding, but let's be honest. My wife gets a hold of the debit card, and somehow subtract happens. So why don't you go to our class library and add a subtract method?
I can handle subtract, because I'm very much a snippet guy.
Oh, in the day we used to call that clipboard inheritance.
Clipboard inheritance. No, it's snippets now. Welcome to the new age.
All right, clean that up. And what I want you to do is add that new method, check it in, okay?
All right. All right.
And come on, you've got IntelliSense, you should be able to get that working.
You'd think so. Okay, so now I have added the subtract method. And
you need
now,
to switch to Solution Explorer.
Yep, now I'm going to go ahead and...
No, switch to Solution Explorer and check in. There you go. See, Program Manager is always in that Team Explorer mode. He wants to run reports and work items. Okay, save it.
All right. So I should probably do a comment.
Do a comment. Come on.
All right, so subtract works. And you turned on the work item policy, so I need a work item.
So you check that. You should be able to use, I think it's 8.
8, okay.
Yeah, you're not resolving a bug, no. We're not letting you do that. Okay.
And check it in. All right. Oh.
Okay, so this is the new gated check-in dialog. Once you've enabled gated check-in, we tell the developer, look, what's going to happen here is we're not going to let you put your stuff completely in the repository. We're going to take your pending changes, put them up on the server via the shelf set architecture. A great feature that's been in 2005, highly recommended for all sorts of other great features. What the team did is they said, look, we've got this infrastructure. We're going to take your pending changes, put it up on the server, and make it available to the account that's doing your builds. It's going to then pull the source down from the repository as it is at this point, get latest. Then it's going to push your pending changes from the shelf set into its workspace, and then it's going to run the build. And based upon the output of said build, it's going to determine whether or not it's going to allow your check-in to proceed. If you're successful, it will push the build in. Why don't you go ahead? Oh, you clicked already. You're letting it run.
did.
Okay. It's going to push the bits into the repository, and you're going to see the check-in was actually finished, not by you, the developer who started the check-in, but the TFS build account. All right, how are we doing there? Did you? No, come on. You got to double-click and let it run.
I did double-click on it. Just give it a second.
More power.
Come on.
Yeah. Okay, the build's running. It's building, validating gated check-in. Okay. And running 43 seconds. Dude, that's like the red X, man. What happened?
I don't know. This is VB, right?
No, we did C#. Sorry, man. All right, so let's go look at your code. Integer math says expected. Dude, you left off the semicolon. How's your pinky, man? You got problems? Yep, obviously. All right. You just back away now from the keyboard, man. All right. So also, you notice Jamie did what some people will do. You know, you're working hard. You go to check-in, you haven't even done a local build. You didn't even do that sanity check. So we're gonna.
You said code, then check-in. You didn't say code, build, check-in.
All right, dude. Back to the day job. All right, so let's go over here and we're gonna check this in. We think it's gonna work now. Oh wait, what's this down here? Oh, you guys may have seen this before. This is the build notification power tool revisited. What they've done is they put it in the box. When you install your appropriate version of Visual Studio with the Team Explorer functionality, you get this notification applet to let you know the status of the build. And what it shows here is that red X of death, check-in failed. Okay, so what we're going to do here is just close this down. I'm going to click build, and we'll start the second build up. And we know it's going to work because I fixed that semicolon thing, but
Details.
details. Give it a couple more seconds. Come on.
You're just lost without being able to watch this.
It just makes me feel better. It makes me feel like the system's doing something. And running for 21 seconds. Zoom in, zoom out. Zoom in, zoom out. Almost there. Build started. There we go. Get a little notification.
You guys chuckle, but I've been watching him do zoom out, zoom in, zoom out for the last 48 hours.
Yeah, that was one of the issues. I was in Berlin last week, and Jamie was in Raleigh, North Carolina, so it was a little hard to practice. There you go. Check-in committed. We're all good now.
Excellent.
Right. So a little more quality has been added to our process.
So now we're sure that all of our check-ins are going to be done from a check-in perspective.
Exactly.
All
But
right.
let me guess, there's more.
There's more. I think so. Okay, so now we know that the code, when we check it in, builds. But it would be kind of nice to know that the code actually does something. So with that, let's talk about automated testing, right? Automated tests, all about not about just getting done, but also staying done. So obviously, the more you can automate, the better. The problem is just cost, right? If we could automate everything, then life would be good, but it is expensive to go and do that. So with VS and TFS 2010, testing in general was one of the biggest single investments that we made. So we have great support across the gambit. So if you want to do manual testing, we have a great test runner offering for enhancing the manual test. If you want to take manual tests and then promote them to automated tests, or just start out from writing automated tests right off the bat, we have good solutions for doing that, from both unit tests all the way up to coded UI tests. And we're going to show you an example of both again. And again, because everything we do in TFS, we try to leverage the fact that we have an integrated solution from top to bottom. We didn't just build a testing solution, we built a testing solution you can integrate with a build system. So you're going to be able to take the build we've already got, after we write some tests, plug them together so that you can run the build and know that the build doesn't only compile, but that it actually works. So, Brian, can we get some tests?
Okay, so first what we're going to do is we're going to add some unit tests. Obviously, if we'd have had unit tests, those of you who do TDD would say, well, look, if you'd have wrote your tests first, you wouldn't even got that far, Jamie. And naturally, now that we've realized the error of our ways, we'll keep him away from the keyboard, but we're going to add a little sanity to our lives as developers. So I'm going to go to integer math, and I have code already. I assume lots of you have code already. You don't always get a chance to write the test first. So I'm going to have Visual Studio help me out and do create unit tests. This is in Visual Studio 2008 Professional and Higher, and continues to be available in Visual Studio 2010 Professional and Higher. We'll create a new test project, click OK. It's going to go through, it's going to read the signatures of the methods selected, and it's going to define tests for each method. So we'll call this test calc engine. Click create. And we'll give it a second. It's adding the project to my solution, generating the test methods. And now if we scroll down a bit, we'll see that it's stubbed out a basic method here. And if we come down here, we'll change this. We'll use the gentleman's math figures from earlier. So we expect 35 plus 7 to be 42. And we'll get rid of this inconclusive, which is there to basically remind you that, hey, this is auto-generated. Come do some cleanup. And we'll go the other way. We'll do something like 84 minus 42. And, of course, the answer is always 42. OK. So now we've got this set up. I'm going to save, do a quick build. And then I'm going to come over here to the test view window, which is available via the test menu. And I'm going to run these two tests. Click and run. And they passed. OK, so I've got the basics there. So now if I start making changes, I can look for them. There's also a great new feature in Visual Studio called Test Impact Analysis that you can use in Visual Studio, that as you make changes to your code, they'll keep track of the tests they think you should run immediately versus having to run your entire test suite. Now that gives us unit tests for the code. And what I can do is have these tests run as part of my build, basically what we call smoke tests or build verification tests. Now what's interesting about this is that I don't have to do anything. By adding that or that test library and having the word test in its name, you'll see that by default, with the default build template, it's going to automatically run in assemblies matching /$test $. So it'll automatically say, is it a .NET assembly? Yes, great. Does it have the appropriate attributes set up in classes? Yes, great. I will run those tests for free. You can, of course, turn this off. You can modify it. And if you prefer using test lists, a feature we've had since 2005, you can still do that, and you can mix and match. So I don't have to do anything. I can just kick this off and run it. So let's run this, Jamie. And, oh, so here's the problem. It's set up right now to run a gated check-in. So I'm going to turn that off because I want to go back to just doing things manually. And go up here to trigger, and we'll turn it back to manual. That way I don't have to do a check-in. Oh, but I might want to do a check-in, right?
I was going to say, yeah. I mean,
well, this would really
even I remembered that one.
That would push the theme of it works on my machine.
I was going to say something, but after the subtract incident, I figured I'd just let you go a little longer.
OK, thankfully there's friends in the audience who are not so kind. They'll let me know that I really screwed that one up. OK. All right, so I could have let a gated check-in work, but I'm going to kick it off manually once the check-in's done. Oh, because it's already updated by another user. OK, fine. By the way, that error just had to do with the fact that we did the check-in earlier, and when I did that, it marked the bug as being resolved already, or the work on it was being done already, so I couldn't change its status. So it's not a bug on the check-in, it was just user error. All right, so that's running. But what I heard you talk about was also this notion of automated tests.
Yeah, well, you know, it's going to be nice here because you're going to know that your coded methods work. But as a program manager, I like to know that the application actually does something useful, that somebody cares about. So could we write a test that actually validated whether the application worked from the user standpoint? OK,
so we have a new feature in 2010 known as a coded UI test. This basically lets you run your application, UX, through its paces as if a human's sitting there behind the keyboard. Now to do this, I'm going to add a separate class library, particularly a testing library, because, number one, I don't want to mix and match my coded UI test, which might be generally worked on mostly by testers, or what Microsoft calls an SDET, with my unit tests, which generally are specific to developer functions and that white box testing with the code. So I'm going to come over here and add a new project, and we're going to this C# node, and I'm going to pick test, and we're going to call this UX automation, PDC, and we'll click OK. And it's going to add a new project to my solution. It's going to set up the references. And what it's basically telling me here is that it added a unit test class because that's the default settings. I can adjust this via tools options, but I'm not doing unit tests, so I'm going to delete this class. What I am going to now do, though, is add, and oh, real quick, notice the green. And notice I didn't look at it at all the whole time.
Very nice. Show them the test results.
All right. Take a look in here. Scroll down. One test run. 100% average pass rate. And if we take a look, the test did pass on the build machine. So that's good. I got no dependencies there. Now, back in the UX Automation PDC project, I'm going to add a new coded UI test. So look, add new test, coded UI. We'll call this just for Jamie.
I'm honored.
Hey, you should feel the love, brother. Now, what's going to happen here, it's going to add a new class, and then it's going to say, okay, how would you like to create this? Would you like us to follow you through the application paces and record it? Or would you like us to take an existing action recording, which has been provided by someone on your test team, and then turn that into a coded UI test that you can modify? So you can do it either way. If your testers have gone through and recorded for you, you can take theirs and modify it, or in this case, we'll build our own. So I'm going to click OK. And what's going to happen here, it's going to minimize Visual Studio. It's going to put up the coded UI test runner, and it's basically saying, I'm ready to go, but I'm not recording just yet. Now what I'm going to do here is open up Windows Explorer, and I'm going to navigate down my directory tree to my workspace, down under Main, PDC Live, come down here to PDC Live WPF. There's my application. So what I'm going to do here is click Record, and now I'm going to launch my application. And we'll enter some numbers. I'm going to do it backwards this time. We'll do 7 first, then 35. Click Add, and once again, applause rang out. Okay, currently recording. I'm done. I'm going to close the application. And I'm going to come down here, and I'm going to click this button that says Generate Code. And we're going to call this Add Test UX. Click Add and Generate. And what it's going to do is it's going to take everything we did and add it to the project via a set of files. One is known as the UI map. The other is the backing class that has the code. So there's an XML file that describes all of the UX objects you interacted. Basically, they work with the accessibility APIs to discover controls, where they live on the screen, grab coordinates, et cetera. Now, the code UI builder is saying, OK, you did that individual test. Do you want to do anything else? No, I'm good to go right now. So I'm going to close this, return to Visual Studio, and now we'll build it. And we'll try it one more time. So we'll come over here to my test view. You notice I now have my coded UI test. I'm going to right-click. I'm going to run it. Give it a second. Hands off the keyboard, and there you go. I now have a coded UI test.
Excellent.
You happy now?
Well,
Thank you, thank you.
Yeah. Well, but I want to have the tests validate as part of the build.
Okay, so you did notice something here. They were able to see what was going on. So I have a live session. My build server, you guys probably can't see it, but if you come up later, we've got a couple boxes that are up here. It's in there. No head, no person. It's a daemon account.
Got it. You actually need to install, you want to be able to install and run the app first. Install the thing.
We got to install it somewhere, and we're going to really need a clean environment because we want it to act like it's a user sitting there at the desktop.
Makes sense. All right, so that brings us up to our next topic.
Okay.
So we have a new feature in 2010 called the Test and Lab Manager. The lab management part is what we're going to talk about now. Effectively, what this is about, there's a lot of apps that you can't test unless you've installed them, unless you've deployed them. If we were building a web application, because we can do all the same stuff we're doing here for web apps, we would need to install the web server, install the database server, get the database stuff populated, right? You need to get a multi-machine environment going for this. So you need to actually really deploy, and that's often a major barrier. It's a major hurdle to get all that stuff done. And it's why you often don't do this manually for special builds. But you'd like this whole process to be automated. So within 2010, we have a new feature called the Lab Manager, where it lets you manage a set of virtual machines as your test lab. So you can automatically spin up, snapshot, tear down VPCs. You can manage machines as individual machines. You can manage them as groups of machines. You can take a set of machines and you can put them in their own isolated network environment. And you can take and make another copy of exactly the same machines and put them in their own isolated network environment so you can run different tests on exactly the same environment but in an isolated way. So we have a lab system that lets you do all of this. And again, to go back to the integration theme, all of this stuff is integrated. So we're able to take and integrate lab in the build. So we're going to be able to do a build, have the build deploy the application as part of the workflow steps to the lab environment that will automatically be spun up, run the tests in the lab environment, and then get the results and report them back. Now, Brian, I happen to notice that you brought pretty much a test lab with you. So I think we might be good to go on that.
Yeah, so let me give you a couple data points. So first of all, if you want to know a lot more about Test Lab, there was a talk this morning by Vinod at 10 a.m., so you want to watch the recording, you can get more details. Let me show you just what we're doing here. So this is actually a virtual machine that's running on a box over here on the stage. And if I go over to my RDP session, you'll see that HVH2 over here, this is my main Hyper-V box running the entire domain. So I've got my Team Foundation server running, which is what you see there. The Win7 client, which I've been doing all my work in. I have a domain controller. There's my build server we've been using. And then we also have what's known as a System Center Virtual Machine Manager installation, something you need to use Test Lab. It basically provides the engine for all the Team Lab features. Right, so all these machines are here. Now the problem is I want to run a virtual machine and run my tests on it. So I needed a second box, and that second box over here is what you see here as HVH1, and this is my box that Team Lab is going to use to run a VM. Now, because there's a lot of infrastructure that goes on in getting the virtual machines set up, getting them deployed and everything, we've done that in advance. In fact, if we come over here back on the Windows 7 client, I have a copy of the Microsoft, Test and Lab Manager. And you'll notice I'm on the Lab tab, and you'll see I have a VM running here. So to put this in context, this is the client machine looking at the Hyper-V server via Test and Lab. And just to put you this context, go back over here to HVH1. If I bring up the Hyper-V Manager, you will see that there's a VM running on this box. 2, 3, 4, thank you. Glad you decided to wake up for me. And there you go. So that's the same VM you see through the client.
Basically, the lab manager is making it so you never have to actually go and do that. You can do everything from your development box.
Exactly. So someone might want to do the initial sys prepping, setting up your base images, et cetera. But in theory, your dev and test lab managers can sit here and do all their work mostly through the lab management console. Now, one of the great things about this is I can connect to it and interact with it or even watch what's going on. So we're going to make sure we can see the environment. And the goal here will be to get the application to deploy and watch the coded UI test run here, not on my local desktop. And what you see here is the test agent saying, I'm connected, I'm ready to go. And no, it's not. It's disconnected. Uh-oh. Nothing like networking joys during the day.
Clearly, the restart button will work.
You think so?
No.
No. Okay, that's good. We'll come back to this because I still have work to do. All right, now, while that's waiting there, when I ran the test, you'll notice what I did. I recorded the test by opening up Windows Explorer, and I double-clicked on it. That then launched the application, put in the numbers, gathered the results, and finished. Well, the problem, if I try to run that on the build server, it's actually stored the desktop coordinates of where to do the double-click. That's not going to work. There's a couple different ways to solve this, and you can parameterize this and set it up. But what I'm going to do is make a change to the actual code. So I'm going to go over here to the definition, and we'll see that there's this code that gets things set up. But the method we want to disable is this call to mouse.doubleclick. So I'm going to comment this out. Yes, I know, changes to my tester and blah, blah, blah. It was one of those dialogues that has more than 3 words, so I'm not even going to read it. Just click OK. There's a class that comes with the test framework called application under test and has a static method called launch. Now, I'm going to do what we normally shouldn't do. Remember, this is demoware. I'm going to add a hard-coded path. What I'm going to do is I'm going to take the bits here, just so I can make sure it works, and I'm going to put it on my machine in a well-known location called C My App. And by having this folder here, I'm also going to have it on my VM. And during the build process, we're going to put it in that directory to make sure it can actually run. If you want to, you can parameterize this, dynamically generate based upon the drive letter or other information, but for now, we're just going to use this. Now, I need to change this path, so let me use the glory that is the clipboard. I just love this little feature. Copy as path. I use this all the time. And we'll go over to Visual Studio, replace these quotes with that path. I'm going to save. I'm going to build. I just want to run it one more time to make sure at least it's running out of there. Now, the big difference is rather than having Visual Studio disappear and them doing the double click, the app's just going to kind of pop up. So let's go to the test view, right click, run selection. There we go. And we're good. OK, so I'm going to check that change in. Okay, modified coded UI test, so it will run unattended. Okay, maybe a little verbose. And we'll just associate a work item because of the rules here. Okay, now let's go back over here to my runner. And we're still disconnected. Okay, so while we're doing that, let's just do a quick restart. Oh, wait, let's do one other thing. So every problem we've had the last day has been due to one thing. Not technology, not beta bugs. No problems there. It's been all networking. I love TCP/IP, not. Come on, NetBUI to the rescue.
So you're saying next time we do this, instead of getting a dev, I should get an IT guy?
Wait, is there an IT pro in the audience? What the hell is that applause for? I thought you were my people. Siding with the program manager. That's just rude. Okay, so the one thing that's going on here is that the build controller, which also has my test controller on it, has to be able to see the lab VM and vice versa. So I'm just going to make sure at least ping works, and if that works, then we'll just bounce the lab VM. Yeah, okay, so that's working fine. So I'm just going to reset that because I now have to go through and set up this extra build because right now our current build is relying upon the fact that it can execute the build on the build server. And what we want to do is we do want to build our bits. We want to compile them. We want to run those unit tests because if that doesn't work, there's no point in trying to run the automated test. But what we do want to do is, assuming that works, take the output of the build and put that into the virtual machine and run the coded UI test there. Now, one little trick you may have noticed or may not have noticed was the fact that when I created the test project for the automated UI test, I did not put the word test inside the project name. That's so it'll be completely ignored by the build process. Once again, you could have manually gone into the build definition and changed it so they didn't use that test moniker. But this way, I don't have to worry about it. For unit tests, we'll just make sure there's test in it. We don't have to do any extra editing of our build definitions. And that just removes extra steps that your build managers have to do. So I've got my build set up for regular unit tests. But now I need to come in here and add a second build. This is going to be my workflow build. So we'll call this PDC Live Workflow. Build it, and then deploy it, and yes, run Jamie's tests.
Are you making that text longer just so you have more time to the VM?
Well, it's back there. It's still disconnected, and I'm really upset because that will make things not work. But we'll come back to that. I will make it work. I still got 17 minutes. Now, the workspace turns out to be irrelevant because I'm not compiling code in this particular build. So we'll leave that alone. Build defaults because it gets cantankerous. I'm going to change this to get rid of the triangle. And now the magic really lies right here in the process. Now, what's going to happen here is I'm going to, first of all, change the template. You'll notice the template says default template. If I click Show Details, you notice there's an option, though, to change this. And the one we're going to use is the lab default template. Once I do this, notice the bottom build process parameters change. Now, before I go in here and run a wizard that's going to let me configure and map the build output to the environment and point to the test, I need to take my coded UI test and link it into the test infrastructure. To do that, I'm going to come over here to my work items, and I'm going to scroll down under my team queries, and I'm going to run a query called my open test cases. And I'm not a tester, so I'm not going to go through the details of what all this stuff is, but basically, for those people who are hardcore into testing, they've set up this nice infrastructure for test cases and test plans and all these rules and things that testers like. Just like developers have rules, testers have rules. And so they have a method to their madness, believe it or not. They're not just out there to make us look bad. So what we're going to do is open up this test plan, or this test case, excuse me, and notice there's an option for associated automation. So I'm going to click this, pick my coded UI test, save it, and what's going to happen is the lab manager is going to look this information up and know which test to run and where to get its metadata. Because there's things like settings, environmental conditions, and basically they track all this so they can say, well, it ran fine on Windows Server 2008, but it didn't run on our Windows 7 environment, for example. All right, we saved that. Now we'll go back over here to the workflow, and we'll run the wizard. Now, as you notice, we have this virtual machine. When you have a virtual machine running under Team Lab, they do this under what's known as an environment. So an environment is at least one virtual machine. For those of you who went to Vinod's talks, you'll notice he did 2. You could have 10. Basically, as much hardware horsepower as you have, you can have in an environment. So you can duplicate entire domain environments. Now you'll notice I have a choice here to pick an already running environment. So the one that's running on the server. Or you can deploy an environment. Now the downside of that is you guys wouldn't get to watch the talk finish, because it would have to load it in a snapshot, copy it from the library onto the server, boot it up, initialize it. So we're going to take the running one, which makes it easier during the day, maybe if you want to run a couple builds at a time. Whereas on your weekend build, for example, you want to run a large test suite, you might want to pull up a clean environment, have it deployed, use snapshots, and all that good stuff. Notice there's an option to revert to a snapshot. This lets you reset or set your VM back to a known good state. So once we run all this test, I'm going to have files on here, I'll have run applications. If I turn on the snapshot option, before it runs the test, it'll apply that and kind of reset the clock. So you can always start from a known good location. I'll hit next, and now it's going to say, well, what do you want to do for your build? Well, notice I can say, hey, just pull from this drop location. This is very useful when you have your known good. Like, we're at beta 2 right now with 2010. So everybody's still beating on this. If we have problems and file a bug with Microsoft, they're going to look at it and they're going to say, okay, yes, it breaks on beta 2. Does it break on our latest build? No, okay, it's been fixed, whatever. But we want to use the latest and greatest from our developers. So we're going to come over here and tell it, I want you to run the PDC live build. Queue it up, run it. So we've got 2 build definitions. One for workflow that now has a child that is our existing compile run unit tests. Okay, next step, deploy the build. Now you'll note here, I'm just going to do one of my favorite things, which is Xcopy deployment. But if you're into more advanced deployment technologies, MSIs, MS Deploy, command scripts, PowerShell, you can do that here too. I'm going to pick my virtual machine, in this case LabVM, and I'm going to say Xcopy the output of my build to my app. Okay? Working directory you can change if it's important, if you're running like a command script or a PowerShell script that needs that starting directory. I don't need that. You'll notice that after deploying the build, I can even take a snapshot. So I've got this idea of known good baseline. Then I've got this idea that I can snapshot everything between known good and just getting the bits out there, and then I can start testing if I wanted to. But we don't need to add the overhead at this point. And last but not least, please run tests. So notice I pick a test plan. So I go to PDC done. It's got my environment set up. I'm using technically 2008, but that really doesn't matter. It's mostly for a tracking piece of metadata for the testers. And then I'm telling it which automated test settings to run. UX Auto basically means it's an automated test environment. That means the build agent test controller need to run in interactive sessions. And we'll select Finish. All right? In theory, we're ready to go, except for one little data point. I now need to deal with this little disconnected issue.
Check the public network setting.
Oh, that's right. So we've been having the joy of networking. So let's come over here to the network, go to Properties. So private network, that looks good.
Could have happened on one of the other boxes too.
Yep, I'm going to go check the build. So as I said, we've been having lovely networking fun. Let's go over here to the build server. Give it a second. And it's on domain. And let's go over here. No, I'm not. That's a great thing to check. Thank you. Let's just make sure it didn't hang at startup or something. So let's go to Administrative Tools. Or we can come over here, All Programs. Why am I seeing? Oh, because I'm clicking the wrong start menu. There we go. There we go. Test Controller. Generation Tool. Hello. Well, this is a good sign that we may have found the problem. The bad sign is it hasn't come back yet. There we go. This account looks good. So let's just double check the services.
Brian has a t-shirt up here for anybody that throws out the magic answer to his problem.
I'll buy you a beer after the talk, too. It's the VSMDI file? Okay, you have to buy me a beer for every special answer you give me. Visual Studio team. Okay, build host is running, test control is running. Let's just do a restart.
Restart this, restart the agent.
I'm sorry?
That was the problem we were having with the network. It would get bumped to a public network, and then we'd hit the firewall setting on the public network. But
oh, I had it. Okay, it's okay.
Oh, it's going to work now.
Yay! Okay.
Okay.
We're done.
Okay,
no.
okay, okay.
Okay. So let me open up the computer. Notice I have a directory called My App. It's empty. Okay. I'm going to go over here. I'm going to queue a new build. And I'm going to walk away. I'm just going to just you guys tell me if it works.
You're going to be able to resist not watching.
I'm not going to watch anything. I'm just going to wait. Because what should happen if everything works is in the background, team build is building the files. It is going to run my unit tests. Assuming that build does not throw up anywhere, the second part of the workflow is going to say, okay, I've now got a successful build. Let me make sure I can connect to the virtual machine. I'm going to deploy the files based upon that deploy option where I typed in the xcopy command. The files will pop up there. Then it's going to go through and say, okay, test control, are we ready? Let's look up the tests that we need to run. Let's look at the automated stuff, and let's make it run. In total, this generally takes about 60 to 90 seconds based upon our current config. I got 8 minutes and counting. We should be able to do this, and if this works, I'm done, man. You have to do summary. I'm just going to lay down here and curl up in a ball and love my life. In fact, that's sadly, that's the problem, right? It's the IT pros. You got to get them to set up your network. When you let a developer set up the network, you run into these kind of issues.
Well, I'm getting nervous.
I want to look.
I'll do it for you.
Okay, you look. You just...
All right, let's go look. It's still running.
It's still running? Okay.
It hasn't.
What is the coded UI test actually?
Okay. One second.
Okay. Questions in a minute. Nobody speak too loudly. Nobody make any sudden moves. Okay. There's a little bit of delay between the things getting the bits getting deployed, and then the tests getting run.
Right. It's going to be talking to that test agent, right? If we didn't have the test agent, this is where we would fail.
Yeah.
Well, where we would.
This is always the part.
This is always hard. I always get kind of excited, want to go look, and he's like, "No, don't look."
No.
The suspense is killing us.
Hey!
All
Good
right.
night.
Okay. Are you okay there?
Yeah, I'm okay.
Okay.
Now, we did get to work, but we kind of threw a lot of stuff at you that we didn't explain. So really quick, let me show them a little bit about the Lab Manager. Now, primarily this tool is not for developers. It is meant for the Lab Manager, the person who runs things, the testers, et cetera. But a couple things that we did here, to be clear, is number one, what you see here is what's called the environment viewer. This provides a nice centralized place to sit there and look at the different VMs and interact with them. Over here in Lab Manager, there's two pieces. There's the Lab Center, which lets us interact and manage the virtual machines. So basically what happens here is you start with a library. Remember I told you about System Center Virtual Machine Manager? What happens is you define your VMs in there and get them basically loaded into a library. And this is where you do things like sysprep, define configurations, et cetera. Then what happens is you go and you bring them into your lab library. Once they're in your lab library, you can define an environment. This is where you define how many different virtual machines you need to do your test suite. Once you've defined that, then you come over here to lab, and you can stop your environments, run it, reset to snapshots, et cetera. I did all that stuff in advance, and a lot of this will be done once or twice, will be done on an occasional basis by your lab manager. This is not something that testers or devs should have to do. Now, the reason why you care about this is that as developers, a tester can find a bug when they're doing something like manual testing. And they will snapshot the environment exactly where they had the bug. And this helps you stop the no repo scenario, because what you can do is take a look at their bug, spin up the environment yourself, log in, take a look at it at that exact point in time, and then really figure out what's going on. In fact, because you can put these VMs on your network, you can even attach a remote debugger. On the other hand, you can do a complete isolated development environment through what's called network fencing, to where you can actually have multiple virtual domain environments. So this is the tool we used. A lot of it was set up, but we were connecting to here. Now the other thing real quick is there's what's called the testing center. The testing center is what your testers are going to interact with a lot more. And this is where I came in and defined some of those settings so that I could run the automated test. Once again, not something you should have to do as a developer on a regular basis, but if you do have to write coded UI tests for them, you're going to have to make sure you at least communicate with them so you can link the two together. Once you've got all that done, you can run it. All right? So you want to wrap this puppy up?
Let's wrap it up. All right. So in summary, I think we've gone from nothing to basically done in less than an hour. We saw a bunch of stuff from automated build, automated testing, builds, lab management. We didn't quite enough time to see the dashboards and reporting the done data, but
no.
No.
No, don't.
We're
We're
done.
done.
Want to see it? Okay. You have,
Okay, you just keep talking.
Okay, yeah,
I'm
like 2
gonna
minutes.
get it up.
So you don't have to adopt all this stuff at once, right? Certainly the lab scenario we showed you is the most advanced of all of these, right? You have to have all the other building blocks in place before it makes sense to take advantage of those. But if you have it, you should take a look, figure out which one of these would make the most sense for you to start with, and kind of start one step at a time. Everything we did here, from the builds to the lab management, was all based off of Beta 2. So you can go to Microsoft.com, Visual Studio, download all the bits that we saw. There's a bunch of docs up there. There's a bunch of other TFS, VSTS, and lab-related talks throughout the conference. You can go and look in the recorded sessions. I think Brian desperately wants to show you one more thing.
Well, I just want to show you that the dashboard is here. It's not that it's broken or anything. One of the downsides to the dashboards at all is that they work off the data warehouse. So even if I wanted to show you the actual metadata about our build and stuff, it wouldn't be there yet because I'd have to kick it, et cetera. But with the new dashboard infrastructure, they've taken the goodness that was SharePoint in the previous release and the goodness that was Team System Web Access and brought them together. So you'll notice I'm a little low resolution, but if we scroll to the side here, I can get to my bugs, I can get to my tasks, I can even look at my test cases. You notice we have 2 that are closed. I have 1 that's in the design phase. Scroll down, we can see our builds. And notice there's the build that we just ran. Okay? So you have a really good tracking point between developers, testers, and other members of your team. And you'll notice we closed the loop here as far as where this information's at. Give it a little more time, the warehouse would update, and we'd be able to see that.
From a program manager perspective, I can always see where the done state is for the project.
And keep you away from the keyboard and writing code.
Maybe.
Yeah. All right, so we have about 2 minutes. If you have questions, please go to the microphone because they are recording. If you don't have questions and you want to run for the hills, thank you for coming to PDC 2009. We're very glad you came.
And I think we can just declare the PDC done.
I think we're done. Thanks for coming.
Thanks.
Bye.
Bye-bye.
Microphones, anybody? Yes, sir, right in front.
I have a question regarding when you're testing multiple browsers and multiple users against your environment, are you going to have those environment in Lab Manager, or should the tester run them from their machines? And it's like a tester running Firefox, IE 6, 7, 8, and so on.
So
Are they going to store them in Lab Manager and pinpoint the machine from there, or, I mean, what's your suggestion?
So the gentleman's question was, if I have, for example, the need to test my web application with multiple browsers, how would I do that? Well, you can do it a couple of ways. You could have a single machine that, if you're going to just do manual testing, that the VM is booted up and the manual tester just runs them all locally. If you want to do automated tests, you could set up multiple virtual machines that each had isolated copies. So if you were worried about interactions, you want to test pure IE6, pure Firefox, you could do that too. It's really up to how you're going to run. You can do it all automated or mix and match. The key is that your testers can share the same base environments between the automated tests and their manual tests. Jamie, you want to answer anything?
That's about right. Yeah.
Okay.
So they should run up in VM in that case.
Well, yes, they don't have to. It's just if you do use Team Lab, it's going to do a lot of work for you. You saw we have the ability to do auto deployment, snapshots. It gives you a lot. You don't have to. You can definitely do all your manual testing, even your automated testing on real machines. There's nothing that says you can't do it without Lab Manager. Lab Manager just adds a lot of value.
Yeah.
Gentleman right next.
That coded UI test that you wrote,
Yes.
Just a little confused as to what that did actually verify at this point. I mean, I knew it run things, but what if the test failed? What if the result was wrong?
So let's say, for example, so two things it's doing for us. Number one, it's actually checking the layout of the application because it's using coordinate space. It's looking for the text box. So if I remove a text box, that's going to be a failure point. Because what happens if they do remove a text box? Oh, documentation is now wrong. The user might not be able to complete their task at hand. So it's looking for changes that are significant in the UX, such as removal of controls. Number two, if you look inside the coded UI file, it's actually tracking the values that were input. So for example, you put 7 and 35, and the answer comes out to be 43. Now granted, we know that won't happen, but think about calculations for purchasing. Say for example, you end up with a bug related to calculating sales tax. We could have a known baseline that says the result should always be $108 because the tax rate is 8%. You run the automated test, the answer comes back at $109. Well, where's the problem? What bug got introduced? It will pick up that. So it does not only test the UX, it tests the actual behavioral interaction, and it does it in a repeatable fashion. Most organizations do this with humans, and don't get me wrong, humans often can do it better because they have the ability to interact with it and think about it. But when you know it should always be A, B, C, D with this particular user interface, with this results, because it's not just UX, it's UX plus the data.
So
The other half of this is that we didn't show you the coded part of the coded UI test. If you didn't want to get, the basic recording will give you a lot of testing value. But if you want to put in your own logic, your own additional validation, you can go do that as well, and that's where the coding starts.
Okay,
Yeah.
that's the piece I was missing. Thank you.
Yeah, sorry, I was lazy. I relied upon everything that they wrote here. But you'll notice how I was able to write this application under test line of code. I can go add all sorts of other code that's going on behind the scenes.
Yeah, basically there's a framework here for writing coded UI tests. There's the recorder that helps you get a lot of default value and a lot of kind of quick start out of the box.
For the rest of you, I'm sorry they're telling us because they got to tear down the room. The convention center's going to kick us out. We still want to talk to you, so please come up here. We'll answer questions as we tear down. We'll go outside in the hall. We'll stand outside. We'll answer all your questions. Thanks again for coming.
Thanks.